Dear fellow students, my topic today is theoretical methods for pricing credit derivatives. I will start first with some definitions, then I will discuss the functions of pricing models, and finally introduce you to some of the most prominent ones. The need of managing credit risk has led to the development of the so-called credit derivatives market. Credit derivatives are such effective financial instruments which aim to allocate credit risk between parties. A popular instrument among others is the CDS, or Credit Default Swap, which is a special type of swap designed to transfer the credit risk of fixed income products between two or more parties. A collateralized debt obligation, or just CDO, is another structured financial product that pulls together cash flow generating assets and repackages them into tranches that can be sold to investors. The first main function of pricing models is to support the intuitive understanding of complex quantities and not leave a place for arbitrage. Another key function is to structure the evaluation of risk in credit derivatives transactions or just portfolios. Capula models used to be the widest used ones among traders before the financial crisis due to their easy implementation. However, those models assume that loans move independently in different states or countries, which is indeed wrong to assume, and they also fail to reflect big data of default movements and to deliver a solid theoretical proof. Structural models, on the other hand, explain the relationship between firms' capital structure and the default risk. Those models are simplified and use basic underlying assumptions. However, such models are considered flawed because prices are derived by historical data and do not consider other important macroeconomic factors. Merton's classical model is one of the most famous structural models. The model assumes that a default will occur in a case of the asset value falling below the debt of the firm. Contrary to Merton's classical model, where default might take place only at the maturity of the claim, in the Black and Cox model, a default could happen at a random point of time. The intensity-based approach is the most widespread one for pricing credit derivatives. Because the models are calibrated to market prices in a very troubleless manner and give a realistic picture of defaultable bond prices dynamics. Intensity-based models examine the factors that influence a specific default event, but they do not explore the motives behind it. Modeling recovery risk is a vital part of credit derivatives pricing models. Modeling positive recovery has been also proposed as an approach in regard of intensity-based models. So this is the connection here. Some of the most important propositions are the zero recovery, recovery of Treasury, multiple defaults, and recovery of market value, and recovery of par. The goal of recovery models is not to reflect the realistic outcome of payment terms or bankruptcy methods, but rather to model the value of settlement. And just a very small example, if the recovery rate is negotiated in, for example, credit default swaps, this does not imply that the obligation must be repaid with them. It simply indicates that the value should equal the value of certain numbers of credit default swaps. The models are also mathematically equivalent, so they do not differentiate from one another on a theoretical basis, which implies no extreme differences in real-life application. However, some recovery models deliver more realistic results than others. So basically, that was my topic. And the main takeouts from it are that credit derivatives are financial instruments which aim to allocate credit risk between parties. Then we have two of the most prominent examples, CDSs and CDOs. Then we've discussed the models, and just a very fast recap. Capula models are easy to implement, but have wrong assumptions regarding the correlation of loans. Structural models explain the relationship between firms' capital structure and the default risk, but they use historical data. In Merton's classical model, default might take place only at the maturity of the claim, and in the Black and Cox model, a default could happen at a random point of time. Intensity-based models examine the factors that influence a specific default event, but do not explore the motives behind it. And then modeling recovery risk is also a very essential part of the pricing models of credit derivatives. Modeling positive recovery has been also proposed, as already mentioned, as an approach in regard of intensity-based models. And some of the most important propositions and examples are zero recovery, recovery of Treasury, defaults, multiple defaults, and recovery of market value and recovery of par. Moreover, the goal of recovery models is not to reflect the realistic outcome of payment terms or bankruptcy methods, but rather to model the value of settlement. So that was my presentation. If there are any further questions, you can also check the abstract of my topic there. You can read a brief summary of what I have said right now. And if you're interested in even further information, you can read my paper. Thank you.